Welcome to another practical class. This is the last experiment for this semester and hope you all have completed the previous experiments writing down in your records. Okay, so please take a fresh new page in your observation book and put the heading. This is a precipitation titration, because in this experiment we find a precipitate is being formed, and using this precipitation or under this precipitation titration we have estimation of Zn+2 ions. Okay, so please put the heading precipitation titration. Under precipitation titration, one more heading, estimation of zinc ions. So generally we start our experiment with the aim of the experiment. So kindly put the side heading aim. Okay, so generally the aim will be to estimate the amount of zinc ions present in the given unknown solution. And next, coming to principle, below aim put the side heading principle. So what is the principle and of estimation of Zn+2 ions? So here we are adding a solution of potassium ferrocyanide, that is K4FeCN6. Okay, so when this solution of potassium ferrocyanide is added to zinc ion solution, a precipitate is being formed. Okay, and when this precipitation process is complete, there will be a change in the color of the indicator from bluish violet to pale green, and the indicator used here is diphenyl benzidine. Okay, and the potassium ferrocyanide that we are using in this experiment is a secondary standard substance, and which can be standardized using standard solution of zinc sulfate. Okay students, please write down the principle. When a solution of potassium ferrocyanide brackets K4FeCN6 is added to a solution of zinc ions, comma, a precipitate of, students carefully write down, K2Zn3FeCN6 is formed, full stop. When the precipitation is complete, color of diphenyl benzidine indicator changes from bluish violet to green. So this is the end point in the experiment, bluish violet to green, full stop. Potassium ferrocyanide is standardized by titrating against a standard solution of zinc sulfate. So below write down the reaction for the principal students. 3Zn+2 plus 2K4FeCN6 gives rise to K2Zn3FeCN6 plus 6K plus. Okay, so this is the principle of the experiment, estimation of Zn+2 with using potassium ferrocyanide. Okay, below write down students indicator is diphenyl benzidine. Next, below end point, bluish violet to pale green, Okay, next. Now comes the procedure students. So obviously step 1 will be preparation of the primary standard solution of ZnSO4. So this ZnSO4 is a primary standard substance. Using the concentration of ZnSO4, we calculate or we determine the concentration of K4FeCN6, that is potassium ferrocyanide, which is the secondary standard substance. So step 1, preparation of standard ZnSO4 solution. Preparation of standard ZnSO4 solution. Underline. Next, write down. Weigh about 2.3 grams of zinc sulfate, comma. So we all know that we need to dissolve it in distilled water in a 250 ml volumetric flask or standard flask, whatever it is, comma, make up the volume, comma, shake well and calculate molarity of ZnSO4 thus prepared. So first step, students, here in the preparation of standard zinc sulfate solution, we find out or we calculate the molarity of zinc sulfate. Okay, next step 2. Standardization of potassium ferrocyanide. Put the side heading, standardization of potassium ferrocyanide. So with the help of ZnSO4 prepared in the first step, we standardize the secondary standard substance, that is potassium ferrocyanide. Fine. So how do we do this, students? Write down. Pipette out 20 ml of standard zinc sulfate solution into a clean conical flask, comma, add 1 test tube of 30% sulfuric acid, 1 gram of ammonium sulfate, comma, 1 test tube of distilled water, comma, 3 to 4 drops of diphenyl benzidine indicator, 3 to 4 drops of diphenyl benzidine indicator, comma, then titrate against. So all these we are taking in the conical flask. Now we have to titrate against potassium ferrocyanide taken in the burette till bluish violet color appears. And continue the titration till a permanent pale green color is obtained. Full stop. Repeat the titration. Why should we repeat the titration? To get the concurrent values. Repeat the titration and calculate the molarity of potassium ferrocyanide. Okay. So using the concentration of ZnSO4, we are calculating or we can determine the molarity or concentration of potassium ferrocyanide. That is the step 2, students. Next, step 3. Estimation of Zn+2 ions. Underline. Now we are supposed to take the we will be given the test solution or the unknown solution, from which we need to pipette out 20 ml of So after underlining, write down. Pipette out 20 ml of the given unknown zinc ion solution. Pipette out 20 ml of the given unknown zinc ion solution into a clean conical flask. Into a clean conical flask, comma, add 1 test tube of 30% sulfuric acid, 30% sulfuric acid, comma, 1 gram of ammonium sulfate, 1 gram of ammonium sulfate, comma, 1 test tube of distilled water, 1 test tube of distilled water, comma, 3 to 4 drops of, comma, 3 to 4 drops of diphenyl benzidine indicator, 3 to 4 drops of diphenyl benzidine indicator, comma, titrate against potassium ferrocyanide solution taken in the burette. Titrate against potassium ferrocyanide solution taken in the burette till bluish violet color appears. Till bluish violet color appears, and continue the titration till a permanent pale green color is obtained. Till a permanent pale green color is obtained. Full stop. Repeat the titration. Repeat the titration for concurrent values. Repeat the titration for concurrent values and calculate molarity of the given Zn+2 ions. The given Zn+2 ions. Full stop. Okay, students, this is the procedure for estimation of Zn+2 ions. Below, write down the result. Put the side heading result. The amount of zinc ions present in the given solution. The amount of zinc ions present in the given solution is dash grams per liter. Dash grams per liter. Okay, students. So now we completed aim, principle, procedure, and also the result. Fine. Next, observations and calculations. Observations and calculations. Underline. Step 1. Step 1. Weight of empty weighing bottle, comma, W1 equals to dash grams. W1 equals to dash grams. Below, write down. Weight of the bottle plus substance. Substance means ZnSO4. Weight of bottle plus substance, comma, W2 equals to dash grams. Next, weight of the bottle after transferring the substance. After transferring the substance, comma, W3 equals to dash grams. W3 equals to dash grams. Next, weight of the substance. Weight of the substance transferred into the flask, comma, W2 minus W3 equals to dash grams. Below, therefore, molarity of zinc sulfate is equal to W2 minus W3 by 287.54 into 1000 by 250. Okay, I am directly giving this formula, students, because you know by now you must be knowing the formula of molarity. Okay, so weight by molecular weight, right? The molecular weight of ZnSO4 287.54 into 1000 by 250, because we are taking in a 250 ml volumetric flask. So is equal to, so whatever value you are getting, that we will substitute and calculate. The value is nothing but the concentration of ZnSO4. Next, step 2. Step 2. So first write down the reaction which is given under principle, that is 3Zn plus 2 K4 FeCN6 gives rise to the precipitate K2Zn3 FeCN6 plus 6K plus. Okay, now comes the table. Take a scale and pencil. Don't draw as you like, students. So take a pencil. So draw carefully the table. Write down first column serial number. Next one volume of ZnSO4. Next column burette readings. Under burette readings we have initial and final. Next column is volume of potassium ferrocyanide. Volume of potassium ferrocyanide. Okay. So serial numbers 1, 2, 3. So if you are doing thrice the titration, volume of ZnSO4 taken 20 ml, 20 ml, 20 ml. Next burette readings initial 0, 0, 0 and final will be at the time when we get the end point. Final minus initial gives us the volume of potassium ferrocyanide, that is the burette reading. Next below write down ZnSO4 versus zinc sulfate versus potassium ferrocyanide. Okay, below write down M1 molarity of ZnSO4, which is nothing but, students, step 1 value. V1 volume of ZnSO4, how much we have taken? 20 ml. Next N1 number of moles of ZnSO4. Look at the reaction. Number of moles of ZnSO4 3. Next M2 molarity of K4 FeCN6, which is to be calculated, is equal to question mark. V2 volume of K4 FeCN6, which is equal to the titer value, that is the burette reading where we get the end point. Next N2 number of moles of K4 FeCN6 from the reaction is 2. Next, below write down the formula, students. M1 V1 by N1 equals to M2 V2 by N2. So, from this step, we calculate molarity of potassium ferrocyanide. Therefore, below write down, therefore, molarity of K4 FeCN6, M2 is equal to, so from the formula, M2 will be equal to cross multiplication mark. M1 V1 N2 divided by N1 into V2. Okay. So what all values we get, we will substitute and determine. We can determine the molarity of the potassium ferrocyanide. Okay. That is the step 2. Next, coming to step 3. The same reaction copied down, which is under the principle 3Zn plus 2 K4 FeCN6 gives rise to K2Zn3 FeCN6 plus 6K plus. Completed? Now, take a scale and pencil. Draw the table. Draw the table. First column, serial number, volume of Zn plus 2 ion solution, burette reading, initial, final. Next, volume of potassium ferrocyanide. Next, serial numbers 1, 2, 3. Volume of the unknown solution we take 20 ml. So 20, 20, 20 ml. Initial reading 0, 0, 0. Final where we get the end point. And final minus initial gives us volume of potassium ferrocyanide. So now below the table, write down Zn plus 2 versus K4 FeCN6. Written below. M1 molarity of Zn plus 2 ions we need to calculate. So is equal to question mark. Next V1 volume of Zn plus 2 ion solution we have taken 20 ml. Next N1 number of moles of Zn plus 2 ions from the reaction it is 3. Next M2 molarity of K4 FeCN6 That will be second step value, students. Okay, step 2 we calculated this molarity of potassium ferrocyanide. That value we will use here. Next, V2, volume of K4 FeCN6 is equal to, this is the burette reading. Next, N2, number of moles of K4 FeCN6 from the reaction, it is 2. Next, below that, write down the formula. M1V1 by N1 equals to M2V2 by N2. Okay, so from this formula, we can calculate molarity of Zn plus 2 ions. So, molarity of Zn plus 2 ions, we denoted it with M1. So, from this formula, M1 can be calculated like this. Cross multiplication, M1 is equal to M2V2 N1 divided by N2 into V1. Okay. So, whatever values are there, we will substitute and calculate, from which we get molarity of Zn plus 2 ions. Okay. Finally, at the end, the amount of Zn plus 2 ions present in the given solution is equal to M1. M1 means molarity of Zn plus 2 ions multiplied by molecular weight. So, M1 into 65, which is nothing but equals to dash grams per liter. Okay, students. So, this is all about estimation of Zn plus 2 ions, which comes under precipitation titration. So, my work is done. I have completed all the experiments. Now, it is your turn to write down all these experiments in your records before the exams. Okay, students, all the best for your exams. So, you all take care, stay home, stay safe, and bye-bye.